Hello, everybody. My name is Galvor. I am a master's student in the environmental science at the University of Idaho. And we are presented today multi-criteria decision-making for recycled municipal plastic waste and a case study in Idaho. I want to start by within a little bit overview of this project, which basically it is to identify environmental release barriers for impacts for the municipal plastic waste that everybody produces every single day. And the solution that that could actually release some pressures for environmental is basically process the plastic waste into a new value-added products such as oil and char for asphalt and other construction products. And in a specific and economic way that is effective for all the stakeholders. This is a little bit of background. The municipal plastic waste that the U.S. produces, we produce about 380 million pounds. Here in the Eastern Idaho, we produce approximately 645 million pounds of plastic waste. That equivalents to, according to the EPA, to the Environmental Protection Agency, to 4.99 pounds per day per capita. And so that the strategies it is to overcome this, it is basically to do a mobile pyrolysis refinery that allow us to be able not just for the plastic to come to us, but actually go to where the plastic is. And this will allow us obviously to process different plastics, not just the specific ones. And in obviously looking at that economic and sustainability, basically we're just looking into the exploration of environmental and techno-economic impacts for the alternative recycle of the MPW or the municipal plastic waste to different products. The life cycle assessment that we did was obviously the goal scope. What the goal was creating the identifying and analyzing the GWP for 100 years, and also looking at the greenhouse emissions, where the system boundary was from grave to gate, basically after the disposal, and take it to to the refinery to be able to come up with the different value-added products. And the scope that we have is obviously three different sectors, which is the upstream, midstream, and downstream sectors, where, as you can see, the input would be the plastic and fuels and lubricants, where obviously the process and the midstream would be the size reduction, converting the plastic into oil and char, and obviously the storage and the transportation for different, maybe different upscaling the oil for the different products. And the functions that that we use in LRB, kilograms of CO2 per 100 metric tons of MPW, and obviously a 1 gallon of oil. The life cycle inventory, we utilize European reference life cycle database in an open LCA, where basically this is the process for production of 1 gallon of oil or P oil, and the open LCA and a convenient LCA method that we utilize. So basically this allows us to understand the environmental impacts and production process of obviously of the waste that is produced daily, and obviously determine the potential effects and optimizing the process through the system boundaries that we have put as you can see it here. As you can see it here, basically this is our materials and methods. This is a basic boundary, and basically, and this the sustainability assessment that we did, and we compare to the current process to process. So, and also we utilize the computer modeling and for the case study in the southeast of Idaho. The process simulator that we do basically at a refinery, the capacity is 50 metric tons per day. or 32,000 metric tons per year. As you can see, basically, we just go from the collection to the pretreatment. This would be also a a portable pretreatment that we resize the size of the plastic. Then we have the refinery, and then after the refinery, obviously, we just go to the storage for the char, and the truck. The tanker truck would be utilized to take the oil to a upgraded refinery. And obviously we have also here the Idaho map here, as you can see, this is the metric tons of plastic that is created, depends on by county. As you can see, Bonneville and Banning are the ones that have the most produced plastic. So, and to become obviously it, to understand that the economics part of this project is we identify, the techno-economic analysis utilizing the TEA model, where we take into account the capital operation costs of pretreatment, conversion, and storage and distribution of 2 mobile refineries. Once again, there's the 50 tons per capacity of each refinery with an annual schedule of 328 days and the 12-hour shifts of production period per day. And these are the processes, obviously the grinding, this is the pretreatment, pyrolysis, the char, the different storages, and the transportations. As you can see, the capital cost will be about $1.2 million, and where the operational cost is, that's where we would see the most significant impact would be about almost $2.8 million, where the utilization rate of the per metric ton would be a $1.2 million per year. And obviously the municipal plastic waste, the results that we come up that we calculated is that we will be able to reduce 50% less emissions than landfill disposal that currently with the current management that there is. That basically results into about 1 trillion of public benefits per year. And as you can see it here, basically that yes, this is obviously 2,261 pounds of GWP that it could be, it will be produced per 100 tons per day. So that it is about 3 to 9 times less than just open field dumping, releasing all the plastic into the environment. So, and a little bit more in depth in the impacts of obviously of the amount of plastic available to utilize, obviously in a cost-effective way. Basically, we utilize the main case study. Once again, is about 3,800 metric tons per year. We utilize different studies. So basically, as you can see, the 3 and 4 studies is we would utilize in the amount of plastic available to us, and the oil production per gallon. Obviously, it is as more as when we increase that amount of plastic process. As you can see, the production per gallon it is way less that we can utilize and be able to be a financial stable as a refinery. And but when it comes to the emissions, as you can see, by increasing 2 times the double the size, in this case 2 refineries instead of 1, as you can see, it would be only 1,000 more 1,000 pounds per metric ton more than just the main case. So which is significant, once again, in a cost-effective way, and also obviously it's kind of like an economic scale. The more you produce, the less it's going to cost. In our conclusions with our project, the environmental impact drivers, it is the fuel consumption. There's about 90%. That obviously it is the for the grinding, the pre-treatment, and also for the conversion and the storage and the distribution. That's where we would see the most, excuse me, the most costs that we see in our study. And as you can see, case studies generate between 1,759 pounds compared to ours would be about 2,261 kilograms of CO2 per, once again, per 100 metric tons of municipal plastic waste. And we believe that the MPW recycling process, the case study that we have done, has a potential to address the plastic waste and recycle management. So that also, once again, it releases a lot of pressure, environmental pressures to our lands and all our water systems. The economic drivers with this will be accessible amount of plastic that we have. As we know that more, as more people come to more dense the community comes, more plastic will be available, and the more impact that it's going to have. So, and also the number of portable refineries that we utilize, the production cost is going to cost less. So I think we those are the main drivers of it. And the further studies that needs to be done, where is basically the exploration of the social and biodiversity benefits to actually account what are the a little bit more explore more in depth of especially in the biodiversity benefits. So what is actually going to count for helping the environment, and also exploration of mix of the different different type of conversion processes, and also a multi-year evaluation instead of 1 year. And obviously the criminalization and policy, I think those are also the drivers or the barriers we need to look at into more detail and see what other cities, what other communities are doing to do this, and what can those policies improve our to be commercialization to be actually grow and be cost effective in a way that everybody can benefit. So just a special thank you to the University of Idaho and the College of Engineering for all the resources and facilities that allow us to do this. And I want to thank you for watching my presentation. If you have any questions, please feel free to reach out to our professor Amin Curry, Amin Arkiwit at ui.idaho.edu, or myself, Albo, ALBO 3236 at bandle.uidaho.edu, or Ethan Strats at Strats 458089 at bandles at uidaho.edu. So once again, thank you everybody for watching this. You guys have a wonderful time. Bye-bye.